Hello everyone. So in this video we are going to talk about how to find the equation of a line. I know you've done this in Algebra 1, but I also want to show you a second way that you could do it. But we'll start off with just doing it the Algebra 1 way that you've already kind of know, and hopefully this is just a refresher. So let's suppose I want to find the line through these 2 points. So this point will be -2, 3, and this point over here will be 4, -1. I'm also trying something out new here in terms of how I make the video, so let me know if this is more helpful or not. You might notice that you can't actually see me drawing or see my pencil drawing as it's drawing, so I don't know, and so the lines will just kind of pop up. I'm not sure if that's gonna take away from the video too much, but with this setup, it makes it a little easier for me to actually make the video. But you'll let me know, hopefully. I just also noticed that you see my little activate windows thing in the bottom corner. I apologize for that. So if you remember from before, whenever we need something from a line, whenever we want to make the equation of a line, we definitely need the slope. The slope is definitely a defining feature of the line, and so that has to show up in the equation. So if we remember, my slope is always rise over run, or to be fancy with it, delta y over delta x. Again, this triangle, that's the Greek letter delta. And I believe that's a capital delta. Yeah, that's capital because the lowercase looks like something else. Okay, so my delta y, or the change in y here, well, you went up from -3 down to -1. And so a way to write that would be to do 3 minus -1. That's going to come out to, a little bit messy here, but that's going to come out to 4. 3 minus -1 would just be +1. Okay, so I know that the numerator of this fraction is going to be 4. Excuse me. And my delta x, which would just be how far this goes, or my run. Well, here's the important part, is if you did the purple minus the blue in one of the delta y or delta x, then you need to do the same order for the other one. And so in this case, I did purple minus blue because I did 3 minus -1. And so I'm going to do the same thing here. So that'll be -2 minus 4, leaving me with -6. Alrighty. If you flip-flop the order, you're going to get the wrong slope and it just won't work out. Okay, so my delta x is going to be -6. Let's simplify this fraction to -2/3. Alrighty, so we're used to using this slope-intercept form. So I'll kind of label that there. That's going to be slope. Let's write this a little better. Slope-intercept form, because, well, it has the slope and it tells you what the y-intercept is. That's what the b is. And so we know what the slope is, but we don't know what b is. So let's plug in what we do know. Equals -2/3 x plus b. And so the question is, what is that? This is where we use our math intuition and figure out, well, what do I know? Remember, x and y are just values that make the graph true. Okay, we actually know a couple values that do make it true, and we actually know 2 points. We know -2, 3, and we know 4, -1. So let's throw in something that we know. So once I plug that in, that's going to leave me with, let's see, y equals 3 in this point. So that's going to be 3 there. -2/3 times -2 plus b. Keep going with this. Let's see, that'll be 3 equals +4/3 plus b. And if I subtract 4/3 from both sides, I believe I'll end up with 5/3, or 2 2/3 equals b. So one equation for this line is this: -2/3 x plus 5/3. Right, so that would be its slope-intercept form. There is actually another way to write this, though. Let's pretend that I'm just trying to go or I want the equation of the line from, again, same point, so I'll do negative 2, 3 to any arbitrary point here, xy. So again, this is just some point on the line, right? And so is this one. It's another point on the line. A point we know is on the line. Is on the line. Okay, and let's suppose I didn't know where xy was. But let's pretend that we know the slope, because it's the same line. So as long as it's the same line, the slope between negative 2, 3 and 4, negative 1 should be the same slope, but from negative 2, 3 to this random xy. So I'm going to draw a line here, mark it off. The slope, which is negative 2/3, should still be what I get when I do my delta y over delta x for these 2 points. So again, this is the same slope, and this is just going to be my rise over run. So in this case, my rise, well, I'm rising from 3 to y, and so I'll do it this way, because this is how you're going to see it, is y minus 3. And then my run, well, since it's going to be I did the y minus 3, so in my delta x I have to do x minus negative 2. Like so. And now this looks kind of arbitrary, but remember, in the in the slope-intercept form over here that I boxed, the first thing we did was we found the slope, and then we still had to find the y-intercept. So there was still a missing parameter there, b. Notice here we actually don't have a missing b. I'm going to work a little bit of math magic here. I'm going to multiply both sides. I'm going to multiply both sides by this x minus negative 2. And just to clear the, get rid of that fraction there. I'm going to do the same thing down here on both sides. How can I write this? Because I ran out of space. I do want to leave it all together. So I'm going to just take this equation times x minus negative 2. And just know that I did that to both sides. I'm not going to do anything crazy here. I'm going to just leave it as negative 2/3 times that equals y minus 3. And I'm just going to rearrange it, flip-flop the sides, because again, this is going to be how you'll usually see it. And you're done, because as long as I know x and y that make that equation true, you have your equation of your line. Now, what exactly do we see here? I want to make 2 observations here. 1, 2/3 is the slope here, so that negative 2/3 is the slope. Another observation right here is that this 3 here and this negative 2, those aren't super random, but we actually see that these are the coordinates for that point that we know on the line. And I probably shouldn't have used blue here, but sorry, this right here. So x equals negative 2 comma y equals 3 is a point on the line. And so notice here, we actually don't need the y-intercept at all, even though we're used to usually having it. This thing right here, that is this fancy thing called a point slope form of the line. So let us generalize it. Point slope form is really just this. It's y minus y1 equals the slope m times x minus x1. So m is usually, again, the slope, and then x1 comma y1 is a point on the line. So even though we're used to finding the slope first and then plugging in one of the points to get the y-intercept, you actually speaking don't really need to do that. Although it definitely is possible. And just to confirm to you that this is actually the same equation, because it should be the same, it is the same equation, so it should give us, I should be able to just rewrite them in terms of each other, or turn one into the other rather. Let's actually do that. So let me scroll over here. Excuse me. So we will take this equation right here. So I'm just going to copy it first. Y minus 3 equals, well, let's distribute, well, sorry, let's just go for it. So I'm going to clean this parentheses up. So this was really x plus 2. So I have y minus 3 equals negative 2/3. So I'm distributing x minus 4/3. And if I add 3 to both sides, I'll get negative 2/3 x. Let's see, negative 4/3 plus 3 would be plus 9/3, which is 5/3. So plus 5/3. Boom, which is exactly what we were hoping for. So that is take a look at point slope form and another way that you could get the equation of a line due to points. Thanks for listening, folks, and thanks for watching.